Are you struggling to understand how to invert differencing in your ARIMA forecast using Python and Statsmodels? You're not alone. This is a common challenge for many data analysts and statisticians. I completely understand how confusing it can be when you're trying to make sense of ARIMA forecasting. It can feel like you're lost in a sea of statistics and code. But don't worry, we're going to break it down together. Here's the specific question we're addressing today. One user asked, how does one invert the differencing after making a residual forecast to include the trend and seasonality that was differenced out? If this sounds familiar, stick around as we explore the solution. To understand this issue, we need to recognize that differencing is a technique used to make a time series stationary. However, once we have our residuals, we need to find a way to revert back to the original scale to include the trend and seasonality. And make sure to stay with us until the end. I have a valuable tip that will help you not only with this problem, but also with future forecasting challenges. To invert the differencing and recover the original series, the user should first retrieve the trend and seasonal components from the seasonal decomposition. This will allow them to add these components back to the forecasted residuals. Next, the user should create a new data frame to hold the forecasted values. This data frame will include the forecasted residuals from the ARIMA model. After that, the user can add the trend and seasonal components back to the forecasted residuals. This step is crucial to recapture the original series. Finally, the user should plot the final forecast to visualize the results. This will show the original series with the trend and seasonality included. Fun fact, the ARIMA model is named after its components: autoregressive, integrated, and moving average. It's like a recipe that combines different statistical techniques to make forecasting more accurate. Now, let's look at the answers provided by other users. An alternative approach suggested by a user emphasizes the importance of considering time trends instead of solely relying on differencing. They point out that ignoring outliers like period 33 can significantly affect your results. The user also notes that the partial autocorrelation function, or PAF, does not indicate a strong seasonal component. They identify a weak seasonal autoregressive pattern with strong correlations in the months of March, April, May, and June. And here's the tip I promised. Always visualize your data before and after differencing. This will help you understand the impact of your transformations and ensure you're on the right track. And there you have it. You now know how to invert differencing in your ARIMA forecasts. Remember, practice makes perfect. If you found this video helpful, please subscribe for more insights and tips on data analysis.